battery testing is very important topic, and we thought it is very mandatory to have a webinar on this topic as well. We have been conducting many webinars on different technical aspects, and this is one of those important technical aspects we wanted to cover. So today's session is we will talk about few fundamental things that why battery testing is important, what kind of different testings are available, right? What is conducted in the industry. Most common cell testings. We'll talk about cell grading. We'll talk about cell sorting. We'll also talk about ACIR and DCIR. Then we will also deep dive in different equipments or testing equipments which are used in the industry. And Mr. Neeraj will take us through the complete portfolio, what they have, and they are a very big supplier for the cell testing equipment inside India and outside India also, right? So with this, let me first introduce you to Mr. Neeraj Kumar Singhal. He is the founder and CEO of Semco Group. He is an avid entrepreneur with more than 26 years experience in the industry. He is the pioneer in country to actually distribute all your cell testing machines to big OEMs also like Ola, Mahindra, Tata, right, and other companies. A big giant with many testing equipments, very strong partnership with global clients and global suppliers as well. And with you, I'm also there today. Vishal Ahuja, who's called co-founder Techlanz. I think you know me from previous sessions as well. I'm IT Delhi alumni with more than 10 experience in the industry. I work with Mahindra, Simple, Vito, and all. Right. So let's with this. Are you excited for today's session? Can you please give me a yes or no in the chat? Are you awake? First of all, I want
Yes,
to
yes,
understand. Yeah, okay. Are you feeling good about today's session? This is a good topic. Great. So I'll be keep on asking you so that although we'll be making the session very engaging, we'll make sure that you are also not sleeping, right? And everyone is awake. So first of all, why the cell testing is required, right? Anyone, any idea like why we do cell testing at the first place? Can anyone even in the chat? Why we do the cell testing at the first place? Many people have different thought process about cell testing, right? Anyone on the chat, can we give me any idea about for cell life? Okay, okay, to ensure uniformity within the battery pack performance. Okay, anyone else? Balancing is not actually that analyze performance characterization of cell parameters. Great. Let me give you from a very fundamental, from very beginning perspective. When the cell are manufactured, right, testing is done to first at the first way to the design validation. So when a experimental cell is also made, the first thing what they do, they make a coin cell and then they do the design validation. Is it meeting my requirement? Right? Then they make a pouch cell. Like for suppose, then they check it whether all my criteria for the voltage, cycle lives, and all those are meeting. So first and foremost, which is done on the lab level, is called design validation. So when you're designing a new cell, it's important aspect of it, right? You have to design validate design also. Second thing is performance validation. So now when you made the cell, now it's something important. You have to test the cell in very different conditions to validate whether consistently I'm getting the same performance and are my performance criteria are meeting. This is a second requirement. That's why you give the. Are you people able to get the audio? Some people have mentioned that I'm not getting the audio. Am I audible to all of you?
Yes, yeah, you are audible, sir. That's not an issue.
Great, great.
Maybe they are facing some issues with their speakers or something else.
Okay, okay, sure. Second thing is if you see that second thing is performance validation, right? Next is quality control. Now you have come out of your design or lab environment. Now you have started producing the cells in the manufacturing unit. Now you want to ensure that you are getting the consistent quality of the cell, consistent performance, consistent life, and all the parameters are under control. That's how you also do the cell testing at the end of your manufacturing line to ensure the quality is there, right? Next thing is your safety assurance. Some tests like short circuit test, underperform, under voltage test, over voltage test, CPT, thermal runaway test. These testings are done to ensure that the cells are safe. They can operate in wide industry condition, in the wide leader life condition, right? So you perform these kind of tests also, right? Then you have regulatory compliances also because all the governments they enforce some kind of regulatory things Like for suppose in India, we have AIS 156, you have UL standards, you have ISO standards, right? So different standards are there to ensure there is uniformity across the cell manufacturers, and then you can test apple to apple, different cells, right? If that's why it's important, because when the government sets a guideline, everyone follows the same guideline and ensures the uniformity across cell to cell, right? One and foremost important thing is digital twin and MBD. When you are trying to build your model-based development approach or digital twin, that time also you need this cell testing data to fit your RC model, to fit your EKF model, and to make your digital twins so that you can predict the behavior of the cell in the field, right? So these are the all reasons because of which you like to perform at cell testing. It becomes very important not only from cell manufacturer perspective, not from the cell user perspective, not from the battery manufacturer perspective, also from the MBD perspective, right? So from end to end, cell testing is very important. This is the most important slide over here, right? Because it's not only performance, not only quality, it's end to end ecosystem which is utilizing the cell testing, right? Now, what are differently widely used cell testings which are there? It is actually categorized in three major categories, which is one is performance testing, where you have IR testing, capacity testing, C-rate testing, temperature performance, self-discharge testing, EIS testing, peak power, ACIR, DCIR, HPPC, fast charging. So these comes under performance category. Here, you would like to see the performance of a cell in different conditions, right? Or with some regulatory conditions as well. Second thing is your life testing, where you like to see how my cell is degrading with respect to time. Under this category, you have SOH or aging testing, cycle life testing, calendar aging, or dynamic stress testing, which consider your real life profile, right? Third category is a major category. I'm saying third category is safety testing or protection testing. Under this, you have thermal runaway testing, nail penetration testing, overcharge protection, short circuit protection. So all these things are under the safety testing. So is this something you are learning something new? Are you finding this useful? Is it making something new for you? Right? So great. So if you see this, what we have done is we have tried to categorize in three major baskets. When you go for understanding cell testing, you will be confused, will blown away, overwhelmed by so many testings. But if you see fundamentally, there are only three categories, right? Under which the cell testing is performed. So sometimes people perform life testing, performance testing, or safety testing, right? Let's go one step below under this, right? So for the quality control assembly, right, let's understand what are the most common testing which are done. Generally, for the quality control perspective on the production lines, you might have heard about cell grading, right? People do the capacity testing for cell grading. But what is cell grading at the first place? Anyone know what is cell grading? Do you know this? What is cell grading? On the chat, I would like to know from all of you. Yes, no, cell grading. It's not live though. Okay. So, Aditya, you're reading this capacity testing and you're sending it based on capacity, right?
Whether it is falling under A grade, B grade, C grade.
Sorry?
Whether it is falling under A grade, that is
Right,
the beginning of life and middle of life. Like
right. Now, if you see this generally at the manufacturing level itself, when the cell is coming out of the manufacturing line, they grade it A, B, C, right? So, whenever you are sending a request to a supplier, you say, okay, I always want grade A cell, right? Everyone, any of the battery manufacturers, they always ask for the grade A cell. They don't ask for grade B cell, and grade C cell is not fit for use at all. Sometimes people sell that also, and that causes thermal runaway and safety issues any which ways, right? But if you see that, and in a bigger perspective, how these companies or the manufacturers, they not only grade based on capacity, they grade based on capacity, internal resistance, and cell discharge rate. So these are the three parameters, major parameters by which they grade the cell. If does not meet if the manufacturer cell does not meet any of these criteria which the manufacturer has set, it they keep them under the grade C cell, right? And based on these ratios, only based on these parameters, they grade them grade and grade B. Now, what happens when they send you, right, these kind of cells. Like for suppose the battery cell supplier is sending you grade A cell. Now you would also want to measure that, right? That okay, whether I'm getting that same capacity or not, right? Because internal resistance and self resistance will talk about it. But you want to keep, like for suppose you're making a battery pack, you want to ensure that all the cells which are there in the battery pack are of same capacity. So what you do, even after receiving the grade A cell from the suppliers, you would like to perform a capacity testing. This is called grading at the battery assembly level, where you separate this all the cells based on capacity, which is called cell grading. And you do internal grading of cells. Okay, this is my 5 Ah cell, this is my 6 Ah cell or 10 Ah cell, right? Okay, someone is posting on the chat. Okay, right. So this is something very important. You have to balance the capacity, so you want all the cells to be of same capacity, right? Next thing is cell sorting. Any idea about cell sorting? Anyone? I want people energy. I want people to interact on the chat. Please, would you know about cell sorting? Okay, while people are chatting, mentioning, right? No, okay. So if you see, this
Sorting
is
based on voltage and internal resistance.
yeah, I have mentioned that already, right? Tejas? Yeah, correct. That is there. The
Cell
cells,
appearance and cell appearance also will include in
correct.
short.
No, yes. If you see that cell sorting, what typically you do at the manufacturing line when you have cells which you have received. Now, for suppose grading is done, you know that all these cells are of same capacity. You would like to grade them based on the internal resistance and voltage, right? Now what you do is you make a group of different cells based on if they have similar IR, which is internal resistance, as well as voltage. Now you group them, right? So you have to somewhere you have to test it out and separate it out, right? But do you know what is DCIR and ACIR? This is most common question which everyone has, right? Do you know what's the difference between DCIR and ACIR? Can you give me in chat? Yes or no? Anyone? Anyone who to speak also can go ahead. Okay. Okay. Let me tell you about what a DCI or ACI, because this is something it is very, very important, right? Let me talk about DCI and ACI also. Now, DCIR, what you do in DCIR, it is direct current internal resistance measurement, where you give a current pulse of 0.2C to 1C for a longer duration of time, which is 1 second to 220 seconds, right? Under that current pulse, right? If you give this current pulse, you see the voltage response of the cell, right? And you measure this delta V, and then you know what's the delta I had given, right? So you measure, I equals to V by R and R equals to V by I, right? So you know that what is the current pulse which I had given, right? And what's my voltage response? Correspondingly, you get the resistance of the cell, which is called DCIR, right? Now, if you see this, there are two major standards for this, which is generally used, which is IEC 61960. Second is ISO 12405, under which you perform the testing, and the C rate changes. But if you see that if you're trying to perform this test on a very high capacity cell, like for suppose you are doing this test on a prismatic cell of 200 right? The C rate can be very high. It can be 100 amps with the current rating will be very high, 100 amps, 200 amps, or like that, right? Which is extremely very high. Now, why you do this? In the process of measuring DCIR, you're trying to measure the overall resistance, not impedance of the cell, which includes your ohmic resistance as well as charge transfer resistance. So in the DCIR process, you measure my overall resistance. So if you know about 2RC model and all, if you have watched our previous webinar also, so all the equivalent resistance which is there, the DCIR is able to capture it, right? Let's see how the ACIR is different than this, right? If you see in the ACIR, what you do, you give a current pulse, AC current pulse of 100 milliamps at 1 kilohertz, which is 1000 hertz, right? Now, if you see the pulses are very different. This is AC frequency which you are trying to give. This was DC pulse, right? and correspondingly you receive a voltage response from the cell, right? And there is always some phase shift between these, right? And this process you measure the impedance, because this is AC now, because this is voltage AC, and correspondingly based on the current which you have given as a AC pulse, you get the voltage response in AC, right? Now, to measure the ACIR, you only take the real part of it, because if you see the impedance, it's a part of imaginary and real part of it. And then you only extract that by neglecting the phase shift which is there, because there is always some phase shift between these two. You only extract the real part of the resistance, which gives you ACIR. Now, from the graphical perspective, if you see this same way, when you have this kind of equivalent circuit model where you are able to capture both the resistance, in ACIR, you only capture the series resistance or ohmic resistance, which is there, right? You don't can consider charge transfer because the frequency is very high. Now, from the frequency point of view, understand the EIS. If you know that, if you see that in the EIS testing, at the high frequency level, you're only able to understand this ohmic inductive region. When you go for lower frequency region, because the AC testing, ACIR, sometimes people do at 1 hertz also, it does not capture the right, let me use a pointer over here. It does not capture the right value of your uh, ohmic resistance, right? Because objective of ACIR is to perform quickly and get this understanding. And this test is quite fast. As contrary to your DCIR, which is taking 1 second, 20 seconds, you can just give a AC pulse and you can get the voltage response and you can very fastly compute this. Now, let me help you understand why this fast response is required, right? Especially in the production line. Let me give you a case study for this. Even before this, even before this. Now, if you see this based on the ACIR and DCIR, you know that the RS, which is ACIR, is only considering the RS part of it, where the DCIR is considering the RS and RT both part of it, right? So that means DCIR will always be higher than ACIR, right? If you see this for any given point of time, if my DCIR is 1 or 10 milliohms, correspondingly, my ACIR is only 7 milliohms, right? So as a rule of thumb, ACIR is around 70% of your DCIR as a rule of thumb. It can be slightly here and there. Did you find this insightful? Did you find this insightful? All these things which I told you right now about DCIR and ACIR. Did you learn something new? Are you finding exciting? Did you know this much detail about the DCIR and ACIR?
Yes.
Okay, great. Right. Now, let me tell you why you are doing this at the first place. It's important to understand that. Now, we talked about the time, right? There is a time difference between the DCR testing and ACR testing. Let's understand that how you would like to do it. You have a current, like simple voltmeter at your home, right? At the multimeter. If you want to test it out, you can still test it out, right? Like you want to do it at the plant level and you want to group this out, you can do the voltage measurement and IR measurement with a multimeter and do the sorting manually for all these cells, right? This will happen. But what if the scale is very high? Let me give an example on the scale of measurement which is there, right? Let me So scale, and let me help you understand why these testings are important and what the scale of testing is required. Now, let's get an example of Tesla Gigafactory in Shanghai, which produces 2,000, 3,000 cars per day, right? The standard battery pack for Model 3 or Model Y contains around 4,000 cells, each battery pack, right? Now, if you just do the understanding on this, the 4680 battery pack of Tesla Model as it has lesser number of cells because their energy density is higher, right? But still in the order of 3,000 to 4,000, right? But so many number of cells in a single battery pack of Tesla, which are cylindrical in nature. That means this gigafactory plant is processing around 8 million cells a day, 8 million cells a day, which is extremely high number, right? Now, would you like to do the measurement by multimeter for each and every cell? And is it humanly possible? Average cycle time for producing a battery pack at the gigafactory of Tesla is around 3 to 10 minutes. Imagine if you try to do with multimeter this kind of measurement for each and every cell, and there are 8 million cells which you need to process. How many people you need, or how many measurement, and what is the measurement accuracy you will get it over there? There will be fatigue in the people and all. Not possible, right? That's how you need automation over here. That is how your cell testing machines come to play, and which helps you to automate these things, right? With this, I would like to hand over the stage to Nilesh sir. Neeraj Kumar Singhal, who is the founder and CEO of Semco Infratech. And then he will talk about the machines what Semco Infratech is using to revolutionize this and do the fast-paced processing of all those times so many cells in the plant level. Nilesh sir, with this, I
Yes,
hand over the stage to you.
yes. So means just give me the rights to share the screen. So I will run a quick presentation and show the images also of the machines for better understanding. Yes, everybody can see my screen?
Yes, sir, the screen visible.
Oh, yes.
Can-
Yeah, so means I will quickly go through the basics about our company and about the machines, which I intend to tell you about the cell testing. So Semco Infratech is a company based in New Delhi and Bangalore, and we provide all the solutions for battery assembly line and testing line. So whatever the processes are used in the battery assembly line, we provide all these kinds of machines. So we are a group more than 25 years group, but means Semco Infratech started only in 2006, and from 2017 we started providing these solutions to Indian market. So we are the distributors of New from China, Hyoki from Japan, and Hein also from China. So means this is basic about our company, and so means now I will tell you. So means if you will see, this is the picture. If you will see, this is the picture of a prismatic cell. So let me focus more on the cylindrical cell. So this is the picture of a cylindrical cell module line. So means in cylindrical cell nowadays to make a pack, we have few semi-automatic automatic lines. So first the cell loading is done, and then the battery is sorted by ACIR and voltage. Then before this process, we already have the machines by which we do charging and discharging of the cells to determine the capacity of the cells. And then the cells are loaded here. Then the cells goes through the sorting process. Then the means it is fed into various systems and welding is done. And then it comes out, and then you do the manual assembly of BMS and various electrical connections on the battery packs, or how putting it into the housing for making a battery pack. So these are the key equipments which are normally used. So this picture is more clear, where you will know the more machines. So number one, where it is written on the top here, this is the cell grading machine. So cell grading is done by charging and discharging of the cells. And once you charge and discharge the cells, so you determine the capacity of each cells. Once each cell capacity is determined, you put the similar capacity of cells in different baskets. This is known as grading of the cells. So the similar type of cells are kept in a separate basket. Then you can also do a paper pasting on the both ends of the cells, so that when you will be making the packs, the current leakage are minimized. Accidental current leakages are minimized. Then you put the cells on the sorting machines, and in the sorting machines, it can automatically sort the cells. Around 3,000 to 4,000 cells per hour it can sort by this automatic machine. It contains an equipment by Hyoki. Hyoki is known for their best equipments for IR testing, and this machine have an equipment known as Hyoki IR 3561 or 3562, whatever the ranges are required, because 3562 is more accurate in the range And whereas 3561 is having a smaller range, whereas 3561 can do the testings up to 5 volt or 20 volts only, and that is the sufficient for this machine, because when we are sorting all the cells only, so no cells goes in voltage above 5 volts. So this is used in the sorting machines. Then means when now you will have the cells sorted out of their capacity and out of means as per their voltage and IR also. So you have now the cells in different baskets, which are mostly same, having the same properties of the cells. Now you make the battery pack out of these cells. So as the cells are welded positively and negatively, so this is a CCD scanner shown at the number 4. This CCD scanner normally tells you that, okay, the cells configuration of negative and positives are kept in the right way in which it is desired. So once the cells passes through CCD scanner, then you take it on a welding machine. So welding machines also comes in various formats. You can do the table welding by manual welding, or you can do the single side welding, or you can do the double side welding. So there are various types of welding machines available with us, and these on this, depending upon your production capacity and the nickel plate thickness you use, different power of these welding machines are available, where you weld all these cells together to make a module. Once the module is made, so this is a BMS tester shown in the number 6. So BMS, all incoming BMSs are tested separately for their functional test. And once this module is made, you install the module and do all the wiring connections, and maybe you also box it or pack it as required. Then it becomes a battery pack. Once the battery pack is made, then you take it on the number 7 machine. This machine is normally this machine is a battery charge and discharge machine. So to determine the battery, means how much capacity as battery pack you are getting. So this also comes in various configurations from 10 volts to 1000 volts and 10 amperes to 1000 ampere equipments are available. Here you charge and discharge the batteries to see the capacity of the final battery pack. Once this battery pack capacity is determined, then there is battery comprehensive test. In this battery comprehensive test, you can measure the various tests, around 14-15 different type of tests. You can do the various tests on battery pack and determine the quality of the battery pack or the various parameters of the battery pack. So this is major about the cylindrical cell or prismatic cell assembly lines. So cylindrical cell and prismatic cell both are more or less using the same kind of machines, but means different because of their different current rating and also because of their different shapes. So this is the normal cell grading machine, which is used for cylindrical cells. It tests capacity, charges and discharges the cells to find the capacity. It performs pulse testing. It also you can also do the cycle life testing on this. This is done to find the exact capacity, to ensure that the capacity level, and this is done, and there is a unique feature in this machine. So once you charge and discharge all the cells, so normally this machine comes in 512 channels. So once you charge and discharge all the cells, so based upon the capacity of the cells, you can give the command from your computer. So the similar cells, means the light will glow on the similar type of cells, so you can take out that cells first, so that cells are of same capacity. This is how the cells are normally graded on this machine. And this comes in different capacities against, like for 18650, normally the 3 ampere machines are used. For 21700, normally the 6 ampere machines are used. Now we have the machines for 10 amperes also, 15 ampere also, 20 ampere also, 30 ampere also, because 30 to 140 cells are coming in the 15 ampere capacity, and lot of people want to do the grading, charging and discharging at 1C rating, so they buy the 15 ampere machine. So means, and this comes up to the 1000 ampere category. So means you can have any different configurations of the machines for cylindrical pouch or the cylindric or the prismatic cells. This is the type of paper pasting machine which I told you, which is also used in the assembly of battery pack to put the insulation paper on the both sides of the cell. This is the cell sorting machine. So this tests internal resistance and sort according to IR. It tests cell voltage and sort it according to the voltage and IR. So means the brown items you may be looking at the machine. These are the different channels. So once the cells are sorted, so the same type of cell will come in each channel. So that's how we call it also the channel. So means normally these machines comes in 5 different channels or 10 different channels, but it can be made up to 20 different channels. So this comes on different machines comes for the cylindrical cells, different machines, different type of cells in the cylindrical also. Like there can be a common machine for a particular length of cells like 18650 to 32700 cells are lengths are same, so you can grade all these cells from one machine, and above that you have the different machines. Like for 140 long cells you have the different machines. For the prismatic cells you have totally different type of structure of the machines, but the principle for testing or on these equipments remains the same. Then this is the cell welder, as I had shown you before also, that it welds the cells on the battery pack as required. This is the BMS tester, and if somebody requires, means they can go on our website, and all these machines are shown there and available there, and they can also follow our channels where we have various channels on YouTube, LinkedIn, for our Semco Infotech page and my page, where we share a lot of information and knowledge for battery packs, for cells, for cell manufacturing also, for various kinds of tests also. So means it is just Google our company name Semco Infotech or my name, you will find all the relevant information where you can go and then follow or like that pages. This is the battery charge dischargers. So means it charges and discharges batteries when the full complete battery is done. And it also have the function of you can also incorporate the temperature function to know the battery's temperature when batteries are charging and discharging. You can also do the charging and discharging at various currents on these batteries to determine how these batteries will perform when different type of currents will be flown through this battery in actual use. And it is also used to test the battery pack life cycles to determine how the batteries are degrading over time. So these are the various different type of battery pack testers as shown. So many. And these are the various kind of cell testers. So first cell machine is for cylindrical cells, second machine is for prismatic cell, then third machine is also for the prismatic cell, fourth machine is also majorly used for the prismatic or pouch cell. So we have clients all over India. We had supplied our machines to more than 300 different companies here in India, and most of the battery pack manufacturers have bought some machines from us. And we are present in Delhi and Bangalore. Major presence we have in Delhi and Bangalore. Near Delhi, we have also our offices, warehouses, and display centers in Saibabad and Greater Noida. So means this is creating unmatched value for the customers, like product development, localization, sales and distribution, after sales support. And we have a very strong after sales support team, and we keep lot of spares also, so that your production is not hampered. We also undertake the AMCs and guarantees the uptime of more than 98% time for our machines. So means why choose us means we have advanced product equipments. So means you can visit our facilities and see all these equipments, strict production management. All the machines which we sell are rigorously tested in our warehouses or centers in Delhi and Bangalore before dispatch. Guaranteed QC management system, professional sales engineers. We have a team of around 25 sales engineers which provide these services, like installation services, support services, after sale services, AMC services all over India. And we perform this all over India. Thank you. So this is a brief presentation of our products. Yes, Vishal, now you can take over and see how to take it forward.
Yeah, sure. And thank you, Neeraj sir. And if you can stop sharing, then I'll be able to share from my side again.
Yeah, 1 second, I need
Sure.
to understand.
And meanwhile, every one of you, are you feeling excited to learn something new with the presentation? What Nirashan has shown. Can you just give me some yes or no? Was it insightful for you? Because as a engineers, we generally don't see the machines and all those things, right? And it's very important to understand what different machines are there which are used in the industry. And that's why we conducted this session, so that help you understand that this is not only the theoretical aspects, this is something which you imply in the industry. So even when you're learning DCIR, ACIR, or EIS machines and all, cell grading, cell sorting, these are not theoretical aspects. This is day in, day out are being used in the industry and had shown you also as the scale of measurement. And Neeraj also mentioned that these machines are capable of handling 3,000 to 4,000 cells per hour, right? Which is a huge number. And humanly, it's not possible at all to do this kind of this one, right? So any questions you have technically on the battery or the testing, what we have considered, right? Please feel free to post them on the chat, right? And some brief about the Techlanz also. Then we can go to the manual question session. You can ask any technical question on any of the technical part or and the services part. Anything we'll talk about it, right? So Techlanz, let me talk about Techlanz also. Some of you, most of you are the people who have been joined us from the community. They know about Techlanz, but let me talk about Techlanz also. We are a ecosystem, EV ecosystem company where we have training programs, we have engineering services. We do these kind of webinars for knowledge sharing for the community as well. We have around 1,300 people in the EV community, right? Very strong community what we have. And we keep on sharing this kind of knowledge freely. And this is a free webinar, all of you know that. But it helps to us to build a very strong community across the globe for the electric vehicle, right? We are startup India certified company. We were started last year, and me and Lokesh are the co-founder of this. We both are IIT Delhi and IIT Kharagpur passed out, worked with industries like Mahindra, Tata, Mahindra, ZF, Ather, right? And four technical people worked in R&D for 11 years only. So that's how we started this Techlanz, to develop the technical competency inside the country and as a community of that, right? Apart from that, we also have our website. You can explore that. You can explore our courses. You can join our WhatsApp community. So Keshav, you can just post the links for those in the chat, as well as Abhishek, if you can post the Semco Infratech link on the chat also, will be helpful for the people to follow those links and go through that.